learners, in this lecture I'll be teaching you about the valencies, like how the electrons should be filled in the orbitals. So there are two conditions by which we can fill the valency. First of all, electronic configuration. Now electronic configuration means the unpaired electrons taken as anticlockwise and other clockwise. Now what is electronic configuration? Let me tell you first. Electronic configuration is like this. First of all, we will place all the electrons. Like in the lithium, we have 3 electrons. First, we will fill this shell. Like, just fill first shell as clockwise, then anti-clockwise. Then, after filling this anti-clockwise and clockwise, we'll have one remaining. So, we'll switch it to the 2s and fill it like the clockwise. Now here we know that this is full paired, like it doesn't need any electron to be stable, but here it is only clockwise, so it needs another electron to be stable. So for that we'll say that it have valency, that is 1. Apart from that, in the beryllium we know that there are 4 electrons. So according to electronic configuration, the configuration would be like this: first clockwise, then anti-clockwise, remaining would be 2, and then it will be clockwise and anti-clockwise. So here it is wrong. Now let me just tell you about the configuration first. Leave these 3. After that I'll be telling that how it is wrong, but let me just tell you what is electronic configuration. So here the nitrogen have 7 electrons. Like we have 3 pairs. You can just simply write it like that, and 1 axis. So how we'll just make it? First of all, we all know that if we are talking about the K shell, let me just tell you. Okay, now this is K shell, and these all are in L shell. So to fill the K shell, we have just put it 2 electrons to fill that, and after that we have just put 2 electrons and 2s because both of them are in x-axis. But if we are talking about the P, so we'll put the axis in the different axes, like in the x-axis, y-axis and z-axis. So here we have 3 valency. After that, an E, that is neon. So for the neon, we know that neon is a noble gas, so it does not have any valency. 10 means first 2, then second 2. Then after putting all these clockwise, we remain with the 3. So we will put it anti-clockwise, so we will got no valency. After that, if we talk about the sodium, we have 1 valency, and it will be on the N shell also. After that, as I told you that there's valency in beryllium, there's valency of 2, but according to the electronic configuration, its valency isn't. So how? Let me just tell you. This is a proof of that. As you know, we just made the valency of lithium 1. But here the electronic configuration of beryllium, boron and carbon, according to the electronic configuration, beryllium has 0 valency, carbon has 1 valency, and boron has 1 valency and carbon has 2. But in the real condition it has 2 valency, it has 3 and it has 4. Now how will we identify that? We identify that by hybridization. Now what is hybridization? It is basically the mixing of the electrons, or we can say that orbitals. Orbitals that has less energy. Like the shape and the energy should be same, can be same, but there can be little bit difference also. Like if we are talking about the P shell and its axis by S shell, so there is bit difference. Like it's in dumbbell shape and it's in round shape. Now there's bit difference in the valency, we can say, or we can say energy. But in the D and S, there is a huge difference. So we cannot hybrid that, but we can hybrid PS2. So in the hybridization, that's the condition that the energy difference should be less. It only occurs in boron, carbon and berylium. Why? Because boron, carbon and beryllium in the reality have different valency, but according to the electronic configuration, it has different valency. Now how we can just find that valencies? Let's talk about that. First of all, for the beryllium, Be. Here we have, like, according to electronic configuration, this is the ground state. Now, when we're talking about the ground state, we'll just excite it. Like, this is the K shell. So it will be filled by 2 electrons. But in the L shell, we'll just fill all the orbitals one by one. If in the beryllium we got 4 electrons, so we'll put it anti-clockwise first. We'll put it anti-clockwise, and after that, if we have any excess electrons, so we'll put it anti-clockwise. So in the beryllium, we have 1 electrons that can be excited. So we'll just put it in the different orbitals, and after that we'll hybride it. Hybridization means we'll mix it, like 2s and 2sp. We'll hybrid it. We'll got sp. Now that should be known that when we are mixing this would be gone there, and after when it will go there, this will be considered as here too. Like the P and L shell becomes equal. If we're talking about the P shell, there would be SP shell. If we're talking about the S shell, there would be SP2. So in the hybridization, we'll just mix it. SP2. Now there's a different orbitals, like this is y-axis and this is x-axis. Sorry, z-axis. But in the beryllium, we have only 2 electrons, like in the S shell and in the PX shell. So we'll just hybridize that. If we're talking about the S, it will be SP. If we're talking about the P, there would be also SP. So that's called hybridization. Let's talk about another example. So in the hybridization of the carbon, we know that the carbon have 6 electrons. So for that, we'll just differentiate in the shells. K shell fully filled. L shell. Now here S is fully filled. This is the ground state, not the full state. We have 4 electrons in the L shell. So what we'll do? We'll put it in the different orbitals as written. In the S shell, then Px, Py, Pz. In the beryllium, there was only 2 electrons, so we just put it in the S and P. But here we have 4, so we have put in it differently. After that, what we'll do? We'll just mix it. Like how? First of all, we'll hybridize these electrons. Why I'm hybridizing it? To become stable. Now how? First of all, the hybridization would occur like this. It's asking that how will it occur? Now as I told you that in the hybridization, there is different condition. Like we'll put all electrons in the different shell. So we'll say that the hybridization in carbon is sp3. sp3 means there are 4 electrons in the valence. If we talk about the boron, there are 5 total electrons and 3 electrons in the L shell. So we'll say that the 1 electron for the S and 2 electrons for the P and P. So we'll say that the hybridization there would be sp2. So that's all about today's lecture.